We're delighted for our next session, for our keynote session at this point right now. Please give a really warm welcome to Mr. Jonathan Gortat, Director of Licensing and Strategic Alliance at Stanford University's Office of Technology Licensing. He's going to share with us the complexity in structuring a solid licensing deal. Now, for those who are interested about partnership or cross-border commercialization, this is for you.
All right, thank you. I'm living in an analog world, so I've got my notes here for my talk. So I've been doing university technology licensing for about the last 20 years. And I often say I've licensed everything from A to Z, which is true. I've licensed apples and I've licensed zebrafish and everything of the other letters in between. I've been at universities that are urban public universities, rural public universities, and now private universities at Stanford. And when people think about licensing complexity, they often think about difficult negotiation points or really dense contract language. But from a university perspective, the real complexity is usually pretty structural. We're often not licensing a finished product. In fact, we almost never are licensing a finished product. We're licensing really early stage technology, sometimes built across multiple funding sources and collaborations with a layered package of rights and obligations in between. The challenge is to translate that into reality, into a deal a company can finance, execute, and live with without losing sight of the institutional and the public interest that also travel with the asset. So in my mind, the task is not merely to transact, it's to translate research into a structure that can move technology forward. The university is licensing something scientifically promising, but commercially unfinished. That means we're not just documenting rights after the value has already been created. And it's more obvious to those who are in the public eye. We're hoping to create a path by which uncertain early innovation can become something investable and usable. Judgment matters a lot in university licensing. So I've structured the talk with 5 key questions, and after question 4, there'll be a brief departure. The 5 questions are: what are we actually licensing? How early stage is the technology? What obligations or encumbrances sit behind the technology? What rights does the company actually need that the university can offer? And then the sidebar there will be a view into AI licensing. And I have that, the obligations around AI licensing after that 4th question, because I really think it covers all 4 of those questions before we move on to the 5th question of how do we move the technology forward without freezing the future. And so if we look at the first question, what we're actually licensing, it can be a lot of things. It could be patent rights, it could be patent applications, it could be software, it could be models, it could be an ontology, it could be a database, it could be know-how coming from a faculty's lab that's maybe not published, it could be materials, it could be AI assets, anything in between. And that package can be a lot of different things. So the real question is not what is the invention, but it's what are the rights does the company need to build value? And then when we think about how early stage the technology is, that's really the most critical part. And I represent this kind of cartoonishly with an iceberg, with what the company sees as the final product, and then how big that iceberg is underneath the water. One of the most important framing questions in university licensing is how early it is. And the company can present us with a product vision, but we're usually licensing a key insight, a prototype, a method, or a proof of concept. We're often licensing a head start, not a finished business. That distinction matters because the structure of the deal should reflect that, what exists today, and not what the company hopes to build later. They still need to do engineering, scale up, validation, they do regulatory work, manufacturing considerations, product market fit analysis, market readiness of the technology, and the more careful we need to be about the scope with the technology when we take into account all those considerations. And then I also have to ask myself, what rights does the company genuinely need at the stage they're at when they're licensing the technology? what a startup company needs might be very different than something that a large multinational company needs. It also means I have to resist the urge to grant the entire downstream future because the science is really interesting. And that's one of the hardest things for licensing managers. Most of us, almost all of us, are former people who worked in a lab for a long time, and we still get really excited about science. But we still have to do what's best for the technology at the end of the day. The practical takeaway is that early stage diligence is called for in defining the field, the milestones, the retained rights of the university, and the future options of the company. We're licensing a technical advantage, not a finished product. And so then we start thinking about obligations that sit behind the asset. So if I think back to when I started in technology licensing almost 20 years ago, it was a lot cleaner. There was a government grant, a patent, and that's what you license. Today and age, there's so many other things to consider. The negotiation may appear bilateral, but the stewardship responsibilities are often broader than the two parties sitting at the table, being the university and the licensee. They have federal funding. There's philanthropic dollars. There's industry sponsorship. There's internal translational funding. There's collaborations between multiple universities. All these things tie into the negotiation of what the university is thinking about when they're licensing technology to a licensee. Each of those things can bring rights, restrictions, reporting obligations, or expectations, especially in today's day and age. So by the time the university presents a company a term sheet, the technology has a huge history behind it that you have to consider as well. A lot of the structural complexity comes from the respecting that history while still creating a workable deal for both parties. Then I have to ask myself, what rights does the company actually need? And this is one where I cartoonishly put a unicorn and a workhorse there. Not thinking about all the unicorns that are on the wall out there from Plug and Play. So maybe I should have done like a winged Pegasus or something that's a little more cartoonish. But you get the idea. A well-structured license grants enough to progress without transferring more of the future than the present justifies. Companies often want broad optionality, and sometimes they do need that real time. Not every company or not every technology needs all fields, all geographies, broad sub-licensing, or every future use case. The question isn't what can be granted, but what is genuinely needed to develop the technology. And that's where those fields come in. The exclusivity, the diligence, the sub-licensing right, and the retained rights all matter. It's not always the broadest package that's most important, it's the one that fits the development plan. And to think about that from a practical perspective, if anybody drove down 101 from San Francisco today, through South San Francisco, you saw huge biotech industry. A lot of those companies were based on Stanford technology that was broadly non-exclusively licensed nearly 40 years ago. So there's 400 non-exclusive licenses that exist that brought about the biotech industry. So that's something to keep in mind for perspective. And then we get to the world of AI today, which is really complex. And one AI deal can contain an entire stack of rights questions. And I put this on a scroll. I actually asked AI to generate this image. What I wanted it to do was scroll through the entire list of things I thought of when I was coming up this slide. But it didn't do that because it couldn't do a 3D animation yet. But we'll get there. So there can be all those things you see on the screen and definitions around what counts as a licensed product or service. The point isn't that every AI deal includes all of these things. The point is that AI makes visible something true more generally. The package matters as much as the economics. The hardest question is not about the price, it's about the scope of the license. So I often start with a few questions. What exactly is being licensed? What can be modified? What can be learned from? And what future value is being transferred? In AI, that product definition is really critical. You have to identify the commercial relationship between the upstream asset and the downstream offering of what's going to eventually be sold. So the upstream asset can have downstream consequences for those people that are easy to underestimate because they're so far away from the market at this time. If I break this down into training data rights a little bit more, a university could have rights for data research, no rights to grant commercial use rights for data. There could be restrictions from data use agreements. There could be restrictions from sponsors, from collaborators, I might need to get patient consent if there's healthcare data involved. There's limited rights to distribute the data itself. And so when I think about this, the university may have developed a model using data. It simply can't hand over for commercial reuse. That said, the model can still be very valuable, even if the data set can't be transferred. And it creates a really nuanced deal design. I can license the trade model without the data. I could permit internal evaluation, but not using the data. I could allow commercial use of the model outputs, but not access to the weights of those models. I could license the code and the know-how separately from the data sets. Or I could reserve the data sets entirely, the rights for the data sets entirely. If I think about retraining and relearning, these are especially sensitive topics. From a university perspective, this is where scope creep in the definitions starts to creep into agreements. Can the company fine-tune the model? Can it retrain from scratch using the same data set? Can it use the license model as a teacher model? Can I use the outputs from the license system to train a successor system? Can customer data be used to continue learning? If so, are those successor models still within the license field, or are they now outside of it? So if I think about upstream university assets, early stage AI deals, retaining rights can be economically larger than the original model grant itself. So that's something to think about when we're considering AI. And so this is the last slide I have. That's interesting. Change the background color, but that's okay. The complexity of this is structural. It's not merely legal drafting. So our perspective at Stanford's Office of Technology Licensing is we plant lots of seeds, we do what's right for the technology, and we're flexible and reasonable. The measure of the license is not only what it grants, but what it creates a credible path to development. A good license should do more than dispense rights. It should create incentives and obligations to make sure that real progress is more likely. That's where diligence matters. It's not just an appendix in the contract. It's the crux of the commercialization strategy. Universities want to avoid technologies being put on the shelf and warehoused, while still being realistic about how long and difficult it is as your job as licensees to go out there and take early stage technologies and bring them to the market. The real question is about what structure gives the technology the best chance to move forward. It's wise to plant broadly, plant lots of seeds, structure carefully, and let the development as it proceeds reveal where the real depth belongs. Not every invention should be forced into the same licensing model. Some technologies need exclusive startup formation for fundraising. Some are better excluded to broad dissemination or non-exclusive dates, or maybe an open source component, or maybe a dual licensing component where there's open source and a proprietary source. Part of the job is to create multiple thoughtful openings and see where that pull emerges from a university perspective. That's what I mean by planting lots of seeds. The office should create options for the technology, not just one perfect transaction. And there's never a perfect transaction. There's always something that could have been better at the end of the day. A good office knows when to be firm, when to be flexible, and how to keep both in service of the technology. Flexibility doesn't mean the absence of standards. It means the applying judgment to actual facts, the technology, the market, the counterparty, the size of the counterparty, the needs of the counterparty. Some issues should be held firmly because they protect the technology and the institution or preserve future flexibility. Other issues are solved pragmatically and help the technology move forward. The goal isn't to win every point, it's to structure something durable and workable. The hardest work often happens before the red lines begin. It lies on understanding what the universities can do, what they control, what obligations attach to the technology, and how to structure a package that enables development without over-transferring the future. That's why the complexity is not just in negotiating the deal, it's in structure. And that's close there.
Thank you so much, Jonathan.
I'll be right.